In this problem, we have a small object with an excess charge of positive 4 microcoulombs and is placed 0.12 meters from another object which carries a charge of negative 7 microcoulombs. We want to first know what is the magnitude of the electric force between the objects, and secondly, we want to know how many excess electrons are on the negative object. We're going to start by drawing a diagram of what we have here. We're going to start. We have a positive 4 microcoulomb charge here, and we have a negative 7 microcoulomb charge, and they are 0.12 meters away from each other. Now, I want to write down our givens, and as we label these things, I'm not going to label them, Q is for charge, I'm not going to label them as Q1 and Q2. Instead, I'm going to label them as Q4 and Q7. I'm going to label them what their actual charges are, because as we get further along in the study, it'll be easier to keep track of them if we label them as to what their actual charges are. So charge 4 is positive 4 microcoulombs, and charge 7 is negative 7 microcoulombs. Our distance, which is r, is 0.12 meters. And as always, our Coulomb's constant K is 8.99 times 10 to the negative 9th. Units are newtons times meters squared per coulomb squared. For letter A, we want to know what is the electric force between the two charges. So we're going to go to our formula. It's a pretty straightforward part for part A. It is Coulomb's constant times the value for each charge divided by the distance squared. Now, what you got to be careful about is we need everything in the proper units. We don't want microcoulombs, we want regular coulombs. But micro means times 10 to the negative 6. And so all we have to do is tack on times 10 to the negative 6 to each number. Well, first we have Coulomb's constant 8.99 times 10 to the 9th. Q4 is 4 microcoulombs. Micro means times 10 to the negative 6. And then Q7 is 7 times 10 to the negative 6. Now notice I'm leaving off the negative because it asks for what is the magnitude, and the negative is not going to tell us direction. The only thing that happens is when you get a negative answer for force, it means that the two are attracting each other. It doesn't mean left or down. If you get a negative, it means that the two charges are attracting each other. So what I found is the negatives really just end up being a source of confusion and a source of problem when we solve more complex problems in the future. So leave off all the negatives when you're solving for the charge, or solving for the force, sorry. The distance is 0.12, and that distance is squared. We get an electric force of 17.5 newtons. Now again, I left off the negative. If you put the negative in there, the negative would only mean that the two charges are attracting. It doesn't mean that one object is moving to the left or one object is moving down. In part B, we're asked to find what is the excess number of electrons on the negative object. That's the negative 7 microcoulomb charge. So in part B, we're trying to find, I'll call N, the number of electrons. Now remember, a single electron has a charge of negative 1.6 times 10 to the negative 19th coulombs. Now, I do want to show you a kind of a shorthand notation. Instead of always writing times 10, another way of writing this is negative 1.6 and then E. This is how your calculator would show it if you have one of those TI-89 calculators or something like that. The E stands for then the exponent. So negative 1.6 with an exponent of negative 19. It's just a little easier to see, especially if you're kind of far away in the back of the room, to write it as such. So just another way of notating these scientific notation values. So we want to know how many of these it takes to equal a total charge of -7 microcoulombs. So how many of these must be added together to equal -7 microcoulombs? The formula then is we're going to say that the total charge is equal to the number of electrons times the charge of a single electron. If I had 2 electrons, it would be -3.2 times 10 to the -19 coulombs. We want to know how many of these had to be added together to equal a total of -7. Remember, this means -7 times 10 to the -6 coulombs. So we now do our substitutions. We have -7 times 10 to the -6 is equal to the number of electrons times the charge of a single electron, which is -1.6 times 10 to the -19. And now divide each side by my -1.6 times 10 to the -19. Just make sure when you're doing this in your calculator that you put parentheses around things, depending on how you have to show scientific notation. We get that the number of electrons is 4.375 times 10 to the 13th. And the units would be just the electrons, the sheer number of electrons we have.